Hello everyone. So this is a new topic called arithmetic sequences and series. Now, this is number of things you need to know in this topic are not a lot, but the questions can get very algebraic, so we'll focus more on the questions. So what is an arithmetic sequence? An arithmetic sequence can be expressed as follows. So you have some starting term A, and then that term gets increased by D, and then you keep on adding D, and so on. So it's a sequence where if you take two consecutive terms, right? So you take A plus D and A, and then you find the difference between them is D. You take the second term and the third term. You take A plus 2D and A plus D. You subtract them, you get D. So everything is just going to differ by D. So this constant value that is getting incremented on each term, this is known as the common difference. So if I say, hey, if I have my second term, T2 means second term, and I subtract my first term, I get this common difference. If I take my third term and I subtract my second term, I get this common difference. And therefore, if I take my nth term and I subtract the term before it, I should get this common difference. So A is your first term. Now, let's look at how I can express the nth term of this series. Well, my first term is just A. This is my first term. My second term is A plus D. That is my second term. My third term is A plus 2D. That is my third term. And therefore, let's think about our nth term. Well, all of these terms have an A in it. So I'm guessing my nth term will also have an A in it, right? Well, what's the relationship? Well, I have 1 and I have 0D here, no D's. I have 1D and I have 2 D's here. So 2 is 3 minus 1, right? 1 here is this 2 minus 1. 0 is 1 minus 1. So therefore, everything is being multiplied to D because there is a D in everything. And then, well, it's this n value minus 1D. So this is the nth term of an arithmetic sequence, A plus n minus 1D. So that is how you find the nth term of an arithmetic sequence. Now, what is a series? A series is just if I take an arithmetic sequence like this and I add up its terms. So if I take A plus D plus A plus 2D and so on. This is an arithmetic series. So if I just have a pattern that follows the rule of arithmetic sequences, that is a sequence. And if I'm adding those terms together, then that becomes a series. Now, what's the one thing you need to know about arithmetic series? You need to know how to find the sum of n terms. So let me just give you a quick example, right? So if I have, say, the numbers, if I ask you to find the sum of 1 plus 2 plus 3 plus 4 all the way up until you get to 100. Well, this would be very hard to do mentally, you would think, but it's not. And when Gauss was 9 years old, he figured out how to do his form of addition. Well, what he was asked to perform this addition, to add the first 100 natural or counting numbers, and he gave an answer almost instantly. And what he did in his head was he said, okay, what happens if I reverse this sequence of numbers, this series of numbers? Well, I would get 100 plus 99 plus 98 plus 97 all the way until plus 1. Now, if I add all the terms together, I get 101 plus 101 plus 101, right? This adds to 101, this adds to 101, this adds to 101, this will add to 101, and this will go on. This will also add to 101. So if I say this was x, the sum is x, and if I'm adding, well, if I just reverse it, that is still x, right? The sum here, the second sum and the first sum, they're the same thing. It's just I flipped the terms. So what I performed was just x plus x. So this has to be 2x. 2x is equal to, well, there are 100 terms, right? there's 1 here, 2 here, 3 here, and on, I have to add together 100 terms. So 100 times 101. And therefore, the sum x has to be 100 times 101 divided by 2. And this should be 50/50. And you can try to add the first 100 numbers, natural numbers together, and you should be getting 50/50. And this is called Gauss's method of calculating the sum of an arithmetic series. So now how do we apply it to general arithmetic series? So let's say if I have a plus d, so I'm adding a plus d plus a plus 2d plus all the way until I get to the nth term. And we just said the nth term is a plus n minus 1d, right? So this is the nth term. So let's say this is s of sum of n terms. Now let me flip everything. Let me say I have a plus n minus 1d plus, this is my first term. If I flip everything, I'm going to get a. In my second term, I'm going to get a plus, well, n minus 1. It's going to be, now what's going to be the next thing, right? Well, n, this should be decreasing. So it's going to be n minus 2d plus a plus n minus 3d. And we go on until we get to a. That is also Sn. So now, if we do the same thing, if we add these two together, I get 2 times the sum of n terms is going to be, now if you check, right? If you check on the side, if I add these two things together, I get 2a plus n minus 1d. If I add these two things together, I have a plus d, and I have a plus n minus 2d, right? And then a plus a gives me 2a, plus I have d from the first term, and from the second term, I have nd minus 2d, right? And then 2a plus d minus 2d is just minus d. So I have nd minus d, and I get 2a plus, if I factor out a d, that is n minus 1d. It's the same thing. And if you add this together, you'll also get the same thing. So I will have, my sum is going to be 2a plus n minus 1d, right? Now, how many terms do we have? Well, we said this is the nth term. This is the nth term. So we will have n number of terms. So I have to multiply by n. And finally, I get that my sum of n terms is n divided by 2, 2a plus n minus 1d. Now, another version of the sum of n terms that you will see is I take s of n is n over 2, 2a. So I will separate 2a as a plus n minus 1d, right? And this is equal to n divided by 2. A is my first term. So let's say that is t1 plus this is my nth term, tn. And what is my nth term? Now, nth term is just going to be my last term. So if you're given the last term and you're given the first term, this is a quicker way to find the sum. So you don't have to plug it in the bigger formula here. And now, is there something more? And one final thing I will mention is that if you have the sum of n terms, right? And you subtract the sum of n minus 1 term, you get tn. And basically what this is telling me is that I have n minus 1 terms, right? Let's say this is n minus 1 terms. And I have already added all of them together. So I know the sum, which is this. And if I'm adding the last term, right? So if I take this to the other side, if I'm adding tn, so this is the expression here. If I add this term, well, that is going to be the sum of n terms. N minus 1 plus 1, that will be the sum of n terms. Sum of n terms. So this is also an important formula to remember. And that is almost everything you need to know for arithmetic sequences and series. I encourage you to go through the worked examples on your own, and let's try to do some questions now. All right. So question 1 says that so let's write down what is given. So the first term, t1, is equal to a, and the common difference is just d. So let's say common difference is d. Write down expressions in terms of a and d for the 7th term and the 19th term. All right. So we want to find Tn. We know what Tn is. Tn is a plus n minus 1 d. So the 7th term, T7, is just going to be a plus 7 minus 1 d. So that is a plus 6d. And T19 is just going to, if you use the same thing, it's just going to give you a plus 18d. So that is what the question is asking you to find. All right. So that is question 1. Now it says, find the number of terms and the sum of each of these arithmetic series. All right. So 2a, I have 13 plus 17 plus 21 plus 90, all the way until 13 plus 17 plus 21, all the way up until 97, I believe, right? All right. So we know that our a, the first term, is 13. Our common difference is take any consecutive terms. So 13 and 17 are consecutive. So I want to subtract 17, the second term, from the first term. Or the nth term, you take away the n minus 1th term from the nth term. So you have 17 minus 13. Always the second minus the first. The second minus the first. The second minus whatever comes before 97. So 17 minus 13, that will give me 4. So I know a, I know d, right? So I want to find the number of terms. Tn, I know, is a plus n minus 1 d. And I want to, if 97 is my last term, I want to solve for n here. So I'm going to put my nth term to be 97. I know a is 13 plus n minus 1. My common difference is 4. So 97 minus 13. If I subtract 13 from both sides, minus 13 minus 13, I get 4 times n minus 1 on my right-hand side, and 97 minus 13, that will give me 84, I believe. And n minus 1 is 84 divided by 4. That is just 21. And therefore, n is 22. So we have 22 terms here. And now we have to find the sum. The sum is just going to be 22 divided by 2. It's going to be n over 2. 2a plus n minus 1d, that is one formula, or it's going to be n over 2a plus l, where l is my last term. This is my last term. So we'll use the second formula because we know the first term, we know the last term. So we'll say 22 divided by 2, that is 13 plus 97, and that is 21 times 110. And that gives me is 2310. Did I... So I believe it should be 2310. Oh, sorry. 22 divided by 2, that is 11. So it's actually 11 times 110. That is 1210. My bad. I forgot to do the division. So 1210 is your answer. So now if you think about it, question 3 is the same, except you're using the other formula. So anyways, so I'll leave B for you to try, because it's essentially the same thing. You see that your nth term is 50. Well, let's just do B anyways. All right. If I'm solving for B, I'm given a series. I know A is 152. My D is going to be take the second minus the first, 149 minus 152. The nth term, take any term, and then you subtract the term before it. So 149 minus 152, the common difference is negative 3. Now I solve for 50. Tn is equal to a plus n minus 1 d. So 50 is my nth term. A is 152 plus n minus 1, we don't know, but d is negative 3. So 50 minus 152, that is going to be 102, I believe. Negative 102 is n minus 1, negative 3. If I divide by negative 3 on both sides, this will cancel out. I get n minus 1. N should always be a positive number, by the way. So that is 34. And therefore, n is going to be 35. And if I know n, I know the last term. The sum of n terms is going to be 35 divided by 2, right? Because I have 35 terms. And then I take the first term plus the last term. And this gives me times the first term is 152 plus the last term is 50. And that is 3535. All right. So now let's try question 3. So I will do A, C, and D. So I'll leave B for you to try. So they have given you the number of terms here. So A is, or I'll leave A to you actually. I'll do B, C, and D. So for question B, right? I have been given my first term is 4. My common difference is going to be 1 minus 4. And that is negative 3, right? And I have been given n is 38. So I have been given that I have 38 terms in the question. So now I just want to find the sum. S of n is n divided by 2. Now we don't know the last term, so we'll just use the formula. 2a plus n minus 1 d is equal to n. So 38 divided by 2. 2 times a is, 2 times 4 is 8, right? A is 4 plus n minus 1. 38 minus 1 is 37 times negative 3. And if you solve for this, you get 8 plus 37 times negative 3 is negative 103 times 38 divided by 2 gives you the final answer. If you solve, if you put everything in your calculator, should be minus 1957. So it should be minus 1957, which it is. And it's the same thing. For part C, you just do the same thing. C is 1 over 3 plus 1 over 2 plus 2 over 3, on and on. So your A is 1 over 3. D is just take 2 consecutive terms and take the difference. I can take 2 by 3 minus this term, 1 by 2. And that is going to be, now let me just show you the butterfly method. You multiply 2 and 2 together, that is 4, minus you multiply 3 and 1 together, that is 3, and you multiply the denominator together, so that is 6. So 4 minus 3 divided by 6, that is 1 over 6. So I know A, I know D, and I know the number of terms. So n is equal to 20. So n is always the number of terms. So now I just do the sum of n terms is n over 2, 2a plus n minus 1 d. So it's going to be 20 over 2, that is just 10. 2 times 1 over 3 is 2 over 3, plus 20 minus 1 is 19, times d is just 1 over 6. So now I can write 2 over 3 as 4 over 6. That is equivalent, right? And I just multiply 2 times 2 and 3 times 2. So 4 over 6 plus 19 over 6. So that is, I believe, 23 over 6. And that is going to be 230 divided by 6. And if you have to write it as a mixed fraction, which the textbook does, so 230 divided by 6 is going to be 38, right? So 38 times 6 is 228. 38 2 over 6, or 38 1 over 3. So that should be your answer. So you can just simplify, but this is also fine. You can also write this as 3, and this is going to be 115. So any equivalent form that you desire. All right. And now question D has some algebraic terms, some variables. So we have minus x minus 5x minus 9x. You might be thinking, well, this is not a sum, this is a difference. Well, we can write it as minus x plus minus 5x plus minus 9x, and so on. And therefore, your first term is a is negative x. Your common difference is take two consecutive terms and take the difference. Minus 5 minus of minus x, right? This minus the first term. So that is going to be minus 4x. And we know that n is given as 40 to 40 terms. So sum of n terms is n over 2, 2a plus n minus 1d. So 40 by 2, that is 20. 2 times x minus x is negative 2x plus 40 minus 1 is 39 minus 4x, right? Because that was the value of d. And now if you simplify, I have 39 times 4, negative 4, is minus 156. Minus 156 minus 2, so in the brackets, I will get minus 158x. And then when I multiply by 20, I get negative 3120x. That is the sum. I think I made a mistake. 39 times negative 4, that is negative 156x. And I have minus 2x times 20. Yep, it's 3160x. So I made a mistake when punching in. Alright, so we know how to do question 1, question 2, and question 3. So now question 4, these are more popular questions. It says the first term of an arithmetic progression is 15. Sum of 20 terms is given to be 1630. And we're asked to find, and we are given n is 20. Remember that sum of 20 terms. So we're asked to find what is d. So this is what we don't know. So let's use the sum of n terms. We know that sum of 20 terms is n divided by 2. So 20 divided by 2. 2 times a. So 2 times 15, that is 30. Plus 20 minus 1 is 19, d. And we know sum of 20 terms. That is 1630. Is 10, 30 plus 19, d. So if I divide by 10 on both sides, I get 163 is equal to 30 plus 19, d. 133 is equal to 19, d. And therefore, so I subtracted 30 from both sides, by the way. And d is going to be 133 divided by 19. And if you put that on your calculator, that is 7. So d is 7. Let's go to question 5. In an arithmetic progression, the first term is negative 27. So a is negative 27. The 16th term, t16, is 78. And the last term, the first term is 27, the 16th term, and the last term. So we'll just call it tn. I'm so sorry about that. So the nth term is 169. So what we are asked to find the common difference and the number of terms. So we are given a is negative 27 and t16 is equal to 78. Well, we know that t16, I can write t16 as in the form of a plus n minus 1 d, right? And we know n is 16 for the 16th term. So a plus 16 minus 1 is 15d is 78. And we know what a is. So negative 27 plus 15d is equal to 78. And we can now figure out what our d value is. So 15d is going to be, you add 27 to both sides. So that is 105. And therefore, d is going to be divided by 15 is 7 again. So now we have found the common difference and find the number of terms. Well, now we know that the last term, nth term, is 167. So we will just substitute 169 is equal to a, which is negative 27, plus n minus 1, and d is 7. So now if I add 27 on both sides, 169 plus 27 gives me 196 is equal to n minus 1 times 7. Now if I divide by 7 on both sides, I get 28 is n minus 1. So I divide by 7, these cancel out. And therefore, n is equal to 29. And now it says find the sum of the terms. Well, the sum of the terms sum of 29 terms is just going to be n over 2. And because I know the last term, I'm going to write it as first term plus last term. So n is 29 by 2, negative 27 plus 169. So 169 minus 7 is 142 times 29 divided by 2. So if you solve everything, so you solve this and then you multiply by 29 and you divide by 2, you get 2059. So that is your answer. So common difference is 7, number of terms is 29, and the sum is 2059. All right. So now these are very similar types of question. It just says in an arithmetic progression. So I think this is exactly the same question, the same type of question. So I will leave question 5 for you to do because it's an arithmetic progression. You're given the first term. It's the same first term as question 4. Oh, okay, sorry. We're looking at the same question. I thought, never mind. Okay, question 6. That was very stupid of me. So the first two terms in an arithmetic progression are this. Okay, we are given T1 is 146. T2 is 139. So we can immediately find D. That is going to be, because these are consecutive terms. So T2 minus T1, 139 minus 146. That is negative 7. D is minus 7. And the last term is negative 43. So Tn is negative 43. And we know A, this is A, we know D, so we can find the number of terms. So we know that A plus n minus 1D is negative 43. What is A? A is 146. 146 plus n minus 1, what is the common difference? Is negative 7 is equal to negative 43. So if I subtract 146 from both sides, I get negative 7 times n minus 1 is equal to negative 43 minus 146. That is negative 189. And now if you divide by 7 on both sides, you get n minus 1 is equal to 27. And therefore, n is equal to 28. So we know n. So we know A is equal to 146. N is equal to 28. And we know that the last term, do we know the last term? Yes. We are given the last term is negative 43. The sum of n terms, because we know the last term is going to be n divided by 2, a plus l. Right? 28 by 2, 14. A is 146. Plus minus is minus 43. So that gives me 146 minus 43 times 14 is 1442. That is your answer for 6. Let's do question 7. The first two terms are given again. So we know A is equal to 2 and A is T1 and T2 is equal to 9. So immediately, common difference is 9 minus 2 is 7. T2 minus T1 gives me 7. The last term in the progression is the only number bigger than 150. All right. Find the sum of all the terms in the progression. So let's think. We start with 2. We're going to 9. We're going to all the way up until, let's say 150. So let's see if 150 is a part of this arithmetic sequence or not. So we will say 150 is equal to 2, which is A plus n minus 1. Common difference is 7. So 150 should be equal to 2 plus 7n minus 7. Or you can subtract actually. You can say 148 is equal to 7 times n minus 1. 148 divided by 7 is 21.142 something is equal to n minus 1. So therefore, n is equal to 22.142 ... So what this tells me is that, hey, 150 is not a part of my sequence because n is not a whole number, right? But if I take, so if if 22.142 gives me 150, then if I take just 22 terms, that's going to be less than, my 22nd term should be less than 150. And you can check. So if I say, hey, my nth term is given to me by A. A was 2 plus 21 times 7. This is 22 minus 1 times 7. 21 times 7 plus 2 is 149. So this is the last term. This is less than 150. So n is 22. N, I have to take 22. Now it says, find the sum of all the terms. All right. 22, and we know, we already calculated that my last term is going to be 149 in the sequence. So now that we have figured that out, we can say, well, my sum of n terms is just n over 2 a plus l. So that is 22 over 2. What is a? A is just 2. Plus what is l is 149. And 11 times 151, right? And that is 1661. That is your answer. It says, oh, it says the last term is the only number that's bigger than 150. My bad. So we have, so I read the question wrong. I'm so sorry about that. So everything, all the calculation still stands, but we have to take 23 terms. Because the 22nd term was 149, which is less than 150. The last term is the only term bigger than 150. So 23 terms, so it's going to be 149 plus 7, right? If you think about it, it's going to be 149 plus 7, because my last term is going to be 149. That was the 22nd term. And if I add the common difference, then I should get 156. That is my last term. So now the sum of n terms should be 23 divided by 2, and then 2 plus 156. So that should be my answer. So I'm sorry I'm making a lot of mistakes in this video. Divided by 2 times 23. So that is 1817. So that is your answer, 1817. So I misread the question. So it says, is the only number greater than 150? So we saw that 22.1 something gave us 150. So of course, the 23rd term would give us something bigger than 150. So you want to take your n to be 23, not 22. My bad. Question 8. So please, I'm so sorry for the mistake, and please please rewind if it got a bit confusing. And yes, question 8. The first term of an arithmetic progression, A is 15, L is 27. The sum of the first sum of 5 terms is equal to 79. So find the number of terms in this progression. All right. L, I know, is just A plus n minus 1d. It is the nth term, right? So that is one thing we should keep in mind. And let's see. And S of 5, the formula for the sum of 5 terms would be 5 over 2, 2a, that is 30, plus n minus 1 d, that is 79. So we don't know what d is, but n minus 1, that should be 4, because n is 5 in this case. So now we can simplify. We can say that, hey, if I multiply by 2 on both sides, the denominator cancels out, and I can simplify. 5 times 30 is 150. 5 times 4 is 20d is equal to 79 times 2. That is 158. And I also know that, so I know that 20d is equal to, now I can solve this equation, right? So that is 8, and d has to be equal to 8 by 20. And 8 by 20 is, I think, 2 by 5. And alright, so now that we know what D is, that gives us, now we can substitute it here, so that we can find the number of terms. So A is 15 plus n minus 1, D is 8 by 20, which was 2 over 5. So that is 27. So now we have n minus 1 times 2 over 5. If you subtract 15 from both sides, I believe that gives you 12. So 12 5s is 6. If you now simplify, this should be giving you 30. N should be 31. So I encourage you to do the simplification on your own. I'm doing it a bit quickly. So your answer is, for 8, is 31. So you want to write down everything that is given and check how you can proceed from that. So it says, find the sum of all the integers between 100 and 300 that are multiples of 7. Well, let's see. What's the first number that is divisible by 7 between these two numbers? Well, I think, so if you do 100 divided by 7, right? You get 14.2 something. So if I do 7 times 14, that would give me something less than 100. So the first number between 100 and 300 that is divisible by 7 should be 7 times 15. So the first number is 105. That is the first number that is divisible by 7. Now 300, you want to do the same thing. If you do 300 divided by 7, you get 42.8. So if you do 43 times 7, that would give you something that is bigger than 300. So I'm going to take 42 times 7. That should be less than 300. So that is 294. So these are your terms. And now we know the common difference. Well, the common difference, if it's a multiple of 7, it's just going to differ by 7. So 105, the next term is going to be 105 plus 7. So that is just, the common difference is just going to be 7. So now we know the first term, we know the common difference, we know the last terms. So there are a few ways to go on solving this. So you can just say, hey, to find the number of terms, my last term is 294. So that should be equal to 105 plus n minus 1, common difference is 7. So 294 minus 105 divided by 7 gives me that n minus 1. So if you simplify this, you get n minus 1 is 27, and therefore n is equal to 28. And now that you know that n is equal to 28, you can just say that sum of 28 terms is 28 divided by 2, that is 14. And your first term is 105, and your last term is just 294. So 105 plus 294 times 14 is 5586. That is your answer, 5586. Question 10. The first term of the arithmetic progression, first term is 2, T11 is 17. And it says the sum of n terms, all the terms, is 500. So we are asked to find the number of terms. Alright, so we know that T11 is just a plus 10d. And that is just using a plus n minus 1d, and n is 11, is equal to 17. So this is an equation that we have. And we know that a is 2. So 10d is just 15. d is just 1.5. Now sum of n terms. Sum of n terms is given by n divided by 2, 2a plus n minus 1d, right? So we don't know what n is. We're looking for n, but we know that, hey, the sum is 500, and if I multiply by 2 on both sides, then this 2 in the denominator will cancel out. So 500 times 2, that is 1000, is equal to n, 2a, a is 2, so 2 times 2 is 4 plus n minus 1. The common difference is 1.5. And 1.5, I can actually write it as 3 over 2. So 1000 equal to 4n plus 3 over 2n times n minus 1. So if I multiply by 2 on both sides again, I get 2000 is equal to 8n plus 3n times n minus 1. So now I have 2000 is equal to 8n plus 3n squared minus 3n. So 2000 is equal to 3n squared plus 5n. And finally, I can say 3n squared plus 5n minus 2000 is equal to 0. And this is a quadratic equation. And we can solve this quadratic equation for n. That is going to be minus 5 minus b plus or minus square root of b squared minus 4 times 3 times negative 2000. That is going to give you 4 times 3 times 2000, 24,000, all over 2 times 3 is 6. So this is using the quadratic formula. Now I'm doing things a bit quickly because I'm assuming that you are getting used to doing these questions. And we've done a lot of quadratic questions in the log chapter as well. So if you simplify this, you get minus 5 plus or minus 155 divided by 6. Now if you do the negative, minus 5 minus 155 will give you a negative answer. We don't want a negative answer, right? So we will do minus 5 plus 155. So that is 150 divided by 6, which is 25. So that is the number of terms. 25 is the answer for question 10. All right. I'm so sorry about that. So Namgi buys a car for this thing. And he pays by making monthly installments in arithmetic progression. So I think, so you are given A, this is A, and you are given N, and you're asked to find the T5. Well, we know that the sum of all the payments has to be equal to the loan that he took, right? So we know that 640,000 has to be equal to 16 is just n. So n divided by 2 is 8. 2 times a is just 32,000 plus 15d. So we can solve for d. So I'm doing things a bit quickly. So 16 minus 1 is 15. The formula tells me that I can multiply by d. So now I have 640,000 divided by 8. So that gives me 80,000 is equal to 32,000 plus 15d. So now if I subtract 32,000 from both sides, I get 15d is equal to 48,000. And d is equal to 3,200. I'm so sorry about that. Now we can solve for T5. And T5 is going to be A, which is 16,000, plus 5 minus 4. 5 minus 1 is 4 times, I know D. That is 3,200. So that will give me 16,000 plus 4 times 3,200. So that is 28,800 niltrum. So I know I solved this a bit quickly, but you get the idea. And we have been, I'm sure we're used to doing the algebra by now. And question 12. That is very similar, right? You're given the first term, you're given the sum of the first 10 terms, you're given the sixth term, you're given the sum of the first 10 terms. So this is very, very similar. T6 is negative 3. A plus 6 minus 1 is 5d is equal to negative 3. And sum of the first 10 terms, that is 10 divided by 2, 2a plus n minus 1d, right? 10 minus 1 is 9. 10 divided by 2 is 5. And the sum of the first 10 term is negative 10 is equal to 5, 2a plus 9d. And if I divide by 5 on both sides, I get negative 2. So now I know that a plus 5d is negative 3, 2a plus 9d is equal to negative 2. So now, if I multiply my first equation by 2, I get 2a plus 10d is equal to negative 6. And now I can subtract. 2a minus 2a gives me 0a. 10d minus 9d gives me d. And negative 6 minus of minus 2, that is negative 4. So that is the common difference. So it says find the first term. So if I know the common difference, that is negative 4, I can easily calculate a. I know that 2a plus 10d is negative 6, right? Or a plus 5d is negative 3. That was the original equation. So a minus 20, because I substitute negative 4 here, is negative 3. A is equal to 17. So that is the first term and the common difference. It's 17 and negative 4. And now, given the nth term is negative 59, find the value of n. It's very easy. Nth term is negative 59. 17 plus a plus n minus 1 minus 4 is equal to negative 59. So if I subtract 17 from both sides, I get n minus 1 times negative 4 is equal to, and negative 59 minus 17 is negative 76. And if I divide by 4 on both sides, I get that n is 19. And therefore, you only solve for n. N minus 1 is 19. You get n is equal to 20. And that is how you solve questions related to arithmetic progressions. I probably will make one more video about this topic. So that is arithmetic progression and arithmetic sequences and arithmetic series. And that is the end of the video.